All right, get ready for this one. Today we're diving deep into something that sounds straight out of science fiction. High-temperature superconductors.
Yeah, they're pretty amazing.
We're talking about materials that conduct electricity with zero resistance.
It's like a frictionless highway for electrons.
I remember learning about superconductors back in school,
Oh, yeah.
but they always seemed like these super exotic things that needed to be cooled to near absolute zero, like practically impossible to make.
Right.
Is that still the case with these so-called high-temperature versions?
Well, that's the incredible thing about them.
Okay.
While high temperature might sound a bit misleading, these superconductors work at liquid nitrogen temperatures,
Huh.
which is still super cold,
Yeah.
but it's a walk in the park compared to near absolute zero.
So it's still cold,
Yeah,
but a lot easier to achieve than those crazy low temperatures.
much easier.
Does this mean we're closer to actually using these materials in the real world?
Absolutely.
Okay, cool.
Liquid nitrogen is easy to get and fairly cheap to maintain,
Right.
which opens up all sorts of possibilities
Yeah.
for real-world applications that we could only dream of with those old-school superconductors.
Okay, so let's talk about those possibilities.
Okay.
I always hear about futuristic stuff like levitating trains and super efficient power grids. Is that the kind of stuff we're talking about here?
You're on the right track. The potential here is massive.
Wow.
Just imagine a world where we can send electricity across entire continents with almost no energy loss.
Wow.
That's the promise of high-temperature superconductors.
No more wasted energy as heat from those long transmission lines.
Right.
That would be amazing for our wallets and the environment.
Definitely.
What else could these materials change?
Well, think about transportation.
Okay.
With the crazy strong magnets we can create using high-temperature superconductors,
Yeah,
we could finally make maglev trains a reality.
like Back to the Future too.
Yeah, exactly.
Zipping between cities at hundreds of miles per hour, floating above the tracks with barely any friction.
Pretty cool, huh?
Okay, now you're speaking my language. Sign me up for a levitating train commute.
Uh-huh.
But I gotta ask, if these materials are so amazing,
Yeah,
why aren't we seeing them everywhere already?
it's a good question.
What's the holdup?
Well, there are still some scientific and engineering challenges to overcome.
Yeah.
One of the biggest ones is that even though we call them high temperature,
Right.
liquid nitrogen temperatures are still way below room temperature.
So we're not quite there yet.
Not quite.
So scientists are trying to find materials that superconduct at even higher temperatures, closer to room temperature.
Exactly.
Yeah.
The holy grail in this field is to find materials that superconduct at or near room temperature,
Right.
which would truly unleash their full potential.
Okay, so the search for new materials is one challenge.
Yeah.
What are some of the other obstacles in the way of making these things mainstream?
Another big hurdle is how complex and expensive it is to make these materials.
Really?
The current methods for making them are costly and hard to scale up for mass production.
So it's not easy to make a lot of them.
Not yet.
Okay.
We need better, more cost-effective ways to make high-temperature superconductors if we want to use them commercially.
So materials challenges and manufacturing challenges.
Yep.
It sounds like there's a lot of work to do before we see levitating trains zipping around.
It's true, but the progress in this field has been remarkable.
How about?
And one of the most fascinating things about high-temperature superconductors is that they challenge our very understanding of how superconductivity works.
What do you mean?
Well, the way traditional superconductors work can be explained by something called BCS theory,
Okay.
which involves electrons pairing up.
Hmm.
But high-temperature superconductors don't really fit that mold.
Oh, really?
They exhibit what we call unconventional pairing mechanisms.
Unconventional pairing.
Yep.
Okay, now I'm really curious.
Uh-huh.
What does that even mean?
So the electrons in these materials still pair up,
Okay.
but the forces holding them together are different.
Different.
Yeah, different from those in regular superconductors.
Ah.
And the exact nature of those forces is still a mystery.
So scientists are still trying to figure out how these electrons are pairing up
Yep.
and creating this zero resistance pathway.
Exactly.
What are some of the leading theories out there?
Well, there are lots of fascinating ideas being explored.
Like what?
Some think magnetic interactions are key, while others focus on the interplay between the electrons and the vibrations of the material itself.
It sounds like a lot of complicated physics going on.
It is.
But before we get too lost in the quantum world,
Okay.
I want to go back to those applications for a sec.
Sure.
I'm especially interested in the potential for these materials to revolutionize power grids. I mean, Transmitting electricity with almost no loss is mind-blowing.
It really is.
The impact on energy efficiency and reducing our reliance on fossil fuels could be huge.
Absolutely.
So let's paint a picture of what that future might look like. I want to understand just how drastically these materials could change our world.
Well, imagine.
So we've talked about the potential for high-temperature superconductors to completely change how we make and distribute energy.
Yes, absolutely.
But I'd love to get a clearer picture of what a world powered by these materials would actually look like.
Oh, okay.
Like, what would actually change?
Well, first of all, those giant power lines we see everywhere,
Yeah.
those would become a thing of the past.
Really?
With almost no energy loss.
Right.
We could transmit electricity underground using much smaller cables, way more efficient.
So no more ugly power lines.
Yep, that's one benefit.
That's a win for sure.
Uh-huh.
But what about the more practical stuff? How would this affect our energy systems as a whole?
It would be a complete transformation.
Wow.
Think about renewable energy sources.
Okay.
Like solar and wind farms, they're usually located far from cities.
Right.
But with high-temperature superconductors, we could send that clean energy over huge distances without losing much of it along the way.
That would be a game changer for renewable energy.
Yeah.
We could finally get over that big hurdle of transporting energy from where it's made to where it's needed.
Exactly.
So a more efficient system
Right.
and greener.
Definitely.
But what about reliability?
Oh, it gets better.
Okay.
Superconducting power grids would be much less likely to have blackouts
Really?
from things like storms or equipment failures.
That's amazing.
Yeah, it would be much more reliable.
Okay, so a more efficient, greener, NED, more reliable energy future.
Yep, that's the goal.
That sounds pretty incredible.
It does.
Let's switch gears for a moment and talk about the materials themselves.
Okay.
I know we talked about how scientists are still trying to figure out those unconventional pairing mechanisms.
Yes.
What exactly are they looking for? What's the missing piece of the puzzle?
Well, the main question is this. What's actually causing these electrons to pair up in these high-temperature superconductors? Is it magnetism, the vibrations of the material, or something else we haven't thought of?
And figuring that out would bring us closer to making materials that superconduct at even higher temperatures.
Exactly.
Okay.
If we can unlock the secrets of how these pairings work,
Yeah.
we could potentially create materials that superconduct at room temperature.
Wow.
Now, that would be revolutionary.
That would be amazing.
Absolutely. It would open up so many possibilities.
Possibilities we can't even imagine yet.
Probably not.
I'm thinking back to those levitating trains. Wouldn't room temperature superconductors make those way more realistic?
Oh, yeah, for sure.
Because right now, one of the
Yeah.
hardest things with maglev trains is keeping those powerful superconducting magnets cold enough to work.
It's a huge challenge.
But if we had materials that could superconduct at room temperature,
Yeah.
that problem would be solved overnight.
Exactly.
So we're talking faster, more efficient transportation.
Yeah.
And I bet there would be huge implications for other technologies that rely on strong magnets.
Definitely.
Like medical imaging.
Right.
MRI machines could be smaller, more powerful, and cheaper, leading to better and more affordable healthcare.
Exactly.
It seems like every time we talk about one potential application, it just branches out into so many more possibilities.
It's amazing.
It's really mind-blowing to think about how far-reaching these materials could be.
Yeah, it really shows how interconnected science is.
Right.
A breakthrough in material science can have a ripple effect
Yeah.
on all sorts of fields.
Like energy, transportation, medicine, and even computing.
Exactly.
Speaking of computing, you mentioned that high-temperature superconductors could play a role in quantum computing.
Yes.
Can you tell me more about that?
Sure.
I'm intrigued.
So quantum computers use the principles of quantum mechanics
Okay.
to do calculations that are impossible for even the most powerful regular computers.
Oh.
And one of the key components of a quantum computer is a qubit.
A qubit, okay.
Now, unlike a regular bit, which can only be a 0 or a 1,
Yeah.
a qubit can be in both states at the same time.
What?
It's called superposition.
That's crazy.
Yeah, it's a quantum thing.
Okay.
And this lets quantum computers do computations in parallel,
Wow.
giving them a huge advantage for certain problems.
So where do high-temperature superconductors come in?
One way to make these qubits
Okay.
is using superconducting circuits.
Mm.
And we can engineer these circuits to exhibit those quantum phenomena needed for quantum computing.
So high-temperature superconductors could help us build better better and more practical quantum computers.
Exactly.
Wow.
Using materials that superconduct at higher temperatures
Yeah.
would make it much easier to build and run these complex quantum systems.
I'm starting to see that we've only just scratched the surface of what's possible with these materials.
Yeah, we're just getting started.
It feels like we're on the cusp of a technological revolution.
It does feel that way.
But I wonder, aside from all the science and engineering challenges, what other hurdles might we face in actually getting these technologies out into the world?
That's a great question, and it leads us to some important things to consider.
You know, we've been talking about all the cool stuff these high-temperature superconductors can do,
Yeah.
but I think we should take a step back for a moment
Okay.
and think about the bigger picture.
You mean like the societal impact?
Exactly. It's not just about the tech itself.
Right.
It's about how it all fits into society and how it might affect our lives.
I agree.
You know, we've been talking about how these materials could revolutionize power grids.
Yeah,
But what would that mean for the people who work in the energy industry?
that's a great point.
A shift to superconducting power grids would probably disrupt things.
Yeah, it could mean job losses.
Exactly.
We need to think carefully about how to manage that change.
It's like any big technological shift.
Right.
There will be some people who benefit and others who don't.
Exactly.
We need to make sure we're not creating a future where only a small group of people win,
Hmm.
while everyone else loses out.
Definitely. And it's not just about jobs either.
What?
We need to think about how this would affect access to energy.
And affordability, too.
Exactly.
Even though we're talking about cheaper energy,
Yeah.
we need to make sure those savings are passed on to everyone,
Right, and that everybody has access to this tech.
not just the rich.
Absolutely.
It's about making sure everyone benefits.
And that we don't make existing inequalities even worse.
Right. And it's not just energy either.
It goes beyond that.
Think about maglev trains
Oh, yeah.
and how they could change transportation in cities.
Imagine how fast cities could grow and connect,
If we had super fast trains,
zipping people around in just a few hours.
it's exciting to think about.
It is.
But it also raises questions
Like what?
about how this new tech could reshape our cities and
Yeah.
how it might affect different communities.
For example, would we see people moving back to rural areas?
If commuting to cities became super easy
Right, or would it just make big cities even bigger and more crowded?
and even more expensive.
These are tough questions we need to think about.
It's a reminder that new technology isn't always a good thing.
It can have downsides too,
There are always trade-offs
and unintended consequences.
that we need to watch out for.
Exactly, and that's why it's so important to have conversations about this.
Discussions between scientists, engineers, policymakers.
And everyday people too.
We need everyone involved to make sure these technologies are developed the right way,
So they benefit everyone.
not just a select few.
I totally agree. It's about using these amazing advancements
In material
to
science,
create a better future for everyone.
a future that's fair and sustainable.
Exactly.
Wow, this deep dive has taken us on quite a journey.
It
We
is.
started with these crazy materials that can conduct electricity without any resistance,
Yeah.
and we ended up discussing the future of our cities
Our energy systems.
and even society as a whole,
It's been a fascinating look.
not just at the science.
But at the bigger picture, too,
It shows how important it is to approach these advancements.
with a sense of wonder, but also with a critical eye.
We need to be excited about the possibilities
But also aware of the potential downsides.
and work together to make sure these technologies truly serve humanity.
Absolutely.
Well said. It's a challenge for sure,
Yeah,
but it's also an incredible opportunity to shape the future we want.
I agree.
And on that note,
Okay.
we'll wrap up this deep dive into the world of high-temperature superconductors.
Thanks for listening, everyone.
We hope you've enjoyed the ride
Yeah,
and that you'll keep exploring the amazing world of science
it's full of surprises.
and its impact on our lives.
Yeah.